Okay, class, we're going to pick up where we left off yesterday, and we're going to talk about the size of megabytes, gigabytes, terabytes. I was actually wrong in class when I said that a gigabyte was a million. A gigabyte is actually a billion. Megabyte is a million bits of information. So megabytes of information, I'm sorry. And we all know that a byte is actually 8 bits. So when you get into the gigabytes and the terabytes, you can see how huge that actually is size-wise in the amount of information that it can store. So moving right along, the next thing we want to talk about is memory. And memory is, there's two different types of memory in the computer, and it's the short-term and the long-term memory. First thing we want to talk about is the RAM, which is a short-term memory. It's basically, it's the place where data, information, and program instructions. When I say program instructions, I mean something like Microsoft Word. Okay, if I tell Word to make something bold, that's going to go into the short-term memory, and that way if I click the bold in Microsoft Word and the next word I go to, it still shows as bold because it's keeping that information in the short-term memory. Now when I turn the computer off, that stuff goes away. So if I put something on my clipboard, those types of things, anything stored in the RAM memory, random access memory, is short-term memory, and it goes away when I turn the computer off, and then when it comes back on, all that stuff is gone. The more RAM you have, the more efficient your computer can run, because you can store more stuff kind of in the basically to randomly access it, just like the name says. So the more RAM you have, the more productive your computer can be, because you have the more ability to process and calculate more information at the same time. This stuff is stored on a RAM chip, random access memory chip, and I'll show you one in class tomorrow. If I don't remember, please remind me and I'll show you guys one. The instruction cycle is the amount of time it takes to receive instructions and to perform a specific task and to complete the command. Guys, this is not on the test. I'll just let you know straight up. Same thing with the execution cycle. The one thing that is on the test is what we talked about yesterday, which was the information processing cycle. But you do need to know that, you know, the stuff that goes into the computer as it gets decoded for processing, that takes time, and the faster your computer is in those particular areas, your computer, the more effective your computer can be. So the execution time, and I think the next slide, yeah, it does show it. The next slide actually shows, you see right here, the instruction cycle. And you remember yesterday when we did that little exercise that showed where we created binary and then we brought it over to the other people and then they decoded it? Well, they were actually the control unit, because it says right here, the control unit decodes the instructions and sends it to the ALU. Now the ALU is the arithmetic logic unit. It's receiving information and needs to determine whether it needs to perform a logical function at that point, an either, an or a not, or an and, an or, or a not. And then from there it will go into the memory and that type of stuff, and then either memory, which would be in the RAM, or go into the output and go through that whole cycle there. But the instruction and the execution cycle work together to create the machine cycle, but just to let you know, that stuff is not on the test. The read-only memory, the ROM, you've heard this term before. It's another type of memory that's found in on the motherboard, and it's actually a ROM chip, and it stores specific information about the computer's operation. It actually tells the computer when you turn it on, when you hit that power button, start Microsoft Windows, because this is a Windows computer. Also want you to start that little login screen. So all those little programs that you have to go through in order to start the computer, that's stored in the ROM. And there's some more essential information, and all that stuff is in something called the BIOS ROM. And it's just simply the instructions on how to start the computer, the sequences. When someone hacks a computer, when a computer gets a virus, usually that's what they're hacking. They're going in and they're editing that part of the instructions on how the computer starts. And unfortunately, when they do that, a lot of times they'll open up vulnerabilities, and that's where they end up either stealing your information or something like that. So but that's all found in the ROM. The ROM is something that it stands for read-only memory. It's not something you go in and change unless you are trained to do that, and you can get to it and change it, but it's not something that a normal person would do on a continual basis. Let's take a look at some different types of storage devices. Storage devices are simply put together to make a copy of the data and to store it and then for you to use later. Now, some of that stuff can be stored on the computer. Some of that stuff can be stored in a what's called a peripheral device, which means it's something that can go away from the computer. Okay, sorry about that. Somebody knocked on my door, so I had to stop. So I'm trying to remember exactly where I was, but let's just move right into storage devices. In order for you to permanently store something, you've got to put it on a storage device. The first thing we're going to talk about is a magnetic storage device. And that means that there is a magnetic sensor that picks up spots of data on the device. The main one you need to know, the hard drive, the hard disk of a computer, is a magnetic storage device. We're not going to worry about file allocation tables. That gets into a little bit of how the data is actually stored, which we're not going to get into right now. But the main thing you need to know is that a hard disk, the faster it is and the more capacity that's on a hard disk, the better it is simply for the performance of the actual computer. Another type of storage device for computers is a magnetic tape. You don't see a lot of these anymore. Usually it's for backup and that type of stuff. There used to be things called 3.5-inch disk and floppy disk and zip drives. We don't just don't see those anymore because it's really outdated technology. With the introduction of USB drives, solid state storage media, there's no reason to use outdated information like that. The optical storage devices, those are DVDs, CDs. A lot of times that's what your games, if you have an Xbox or a PlayStation or whatever it is nowadays, those things usually come on disk. Those are optical, meaning that there is a scanner. As this disk spins, there's a scanner that reads all the little indentions, basically little grooves. If something were to scratch a disk, then it messes it up. It distorts that data. It makes it corrupt. So that's an optical storage device. Those are your CDs, your DVDs. Solid state media. This is kind of the new thing now. Why would you want to have moving parts when you don't need them? It takes more energy to run moving parts, which means battery life and things like that go away. So solid state media, it's the biggest one you see right now is a USB flash drive. It's simply made of integrated circuits. There's no moving parts. The other thing that you see, and it's not in the presentation here, but now you're starting to have laptops with actual solid state hard drives. So there's no moving parts at all, which helps extend the battery life and that type of stuff. Network drives, those are usually hard drives, servers, things like that. And then sometimes there are tape drives. It's called DAT, which is digital audio, I don't remember exactly, tape, digital audio tape, yeah. And it stores the data, but and that's used a lot of time by multiple users. For example, I'm able to access all of the information on the Ascension Parish School Board's website by using PowerSchool, and you do the same thing. Well, that stuff is all stored somewhere else on a network drive, and that everyone shares that information. So simply caring for storage media, I'm going to just go over this real quick. You know that if a device is magnetic, then you don't want to have a huge magnet go over your computer. You see that in hacker movies where a lot of times if the FBI busts in, they take a big magnet, an electromagnet, and they wipe the computer's memory real quick so that nobody gets that information. You want to avoid extreme temperatures. You want to make sure you store them in proper places where it's not too cold, not too hot, or not too wet. Handling DVDs and optical disc, obviously you want to hold them on the edge of the disc. You don't want to hold them near the right in the middle because it puts fingerprints, grease, things like that, which again messes it up when it's trying to be read because it is optical. Never try to remove media from the indicator light when it's on because it's spinning and being read, and so and then keep disk in a sturdy case when transporting. Just real quick, the computers of the future, one of the major areas that is going to evolve is connectivity, and you're seeing that now. You're seeing things like ETEL with the fiber edge, everything coming in via, what is it called, that fiber optic. The speed, what's called throughput of data is just so fast, and that's getting better and better. You're seeing and living the onslaught of wireless and mobile devices. It is becoming the norm. It absolutely is the norm. And then what we're looking at here, computer literacy, which is the class that you're taking in a sense, it's so important that you guys understand this information. So that's all we have for today. I will see you in class. I hope you have a great evening.